Right now, millions are walking around with high blood sugar, completely unaware. The early stages of this epidemic present with zero outward symptoms, but beneath the surface, elevated glucose acts like a slow-moving corrosive agent. It steadily erodes the lining of blood vessels, damages the delicate wiring of the nervous system, and it severely stresses the kidneys and heart. By the time a doctor actually diagnoses the condition, this internal wear and tear has usually been occurring silently for years. The condition develops through a gradual, systemic breakdown of the body's internal energy network. Eating too much sugar is often blamed as the sole cause of diabetes. In reality, type 2 diabetes is a complex metabolic failure. We can see how this works at the cellular level. In a healthy system, a hormone called insulin acts as a signal. It instructs the cell membranes to absorb glucose from the bloodstream to be used for energy. But in a state of insulin resistance, those cellular boundaries become unresponsive. The cells stop absorbing the glucose, and the normal transfer of energy completely stalls. With nowhere to go, that sugar backs up into the bloodstream. This creates an immediate oversupply, a rising tide of glucose that exerts a toxic pressure on the entire circulatory system. When the body's automatic hormone regulations fail, the system requires manual intervention to bring that blood sugar back under control. The very first manual override involves controlling the incoming supply of glucose. Medical research consistently points to high-fiber foods as a primary tool for doing exactly that. Foods like lentils, beans, vegetables, and especially oats and whole grains act as a physical buffer in the human diet. Taking a look inside the digestive pathway, we can see why. Oats, for example, contain a specific soluble fiber called beta-glucan. When digested, it mixes with water to form a viscous, gel-like trap that physically tangles up incoming sugar molecules. This chart overlay shows the effect. By physically slowing down how fast the sugar can be absorbed into the blood, this fiber flattens out what would otherwise be a sharp, dangerous post-meal blood sugar spike. As an added benefit, these exact same fibers travel further down to feed beneficial gut bacteria, which scientists have linked to improved overall insulin sensitivity. By prioritizing fiber at every meal, you mechanically throttle the supply of glucose, ensuring your metabolic system never becomes entirely overwhelmed. Throttling the supply is only half the equation. Any excess glucose that does make it into the bloodstream still needs an active mechanism to clear it out. That brings us to the second manual override, creating immediate physiological demand by taking a simple 10 to 15-minute walk right after eating. The moment you start walking, large leg muscles begin to rhythmically contract. Every contraction fires up a biological engine, requiring immediate, accessible fuel. To get that fuel, contracting muscles pull glucose directly out of the bloodstream. Crucially, this muscular demand bypasses the insulin-resistant cell signaling we saw earlier. This active biological demand contrasts with the reality of modern life. Sitting still for hours after a meal creates biological stagnation, leaving that sugar trapped in the blood with nowhere to go. Light post-meal movement serves as a manual exhaust valve. It actively burns off the incoming sugar before it can begin damaging the blood vessels. When you pair these two interventions together, limiting the supply with dietary fiber while stimulating the demand with physical movement, you create an optimal environment for blood sugar control. Despite marketing claims, no single superfood, supplement, or diet plan can independently fix a failing metabolism. Long-term metabolic health relies on a much broader set of compounding factors. Elements like getting adequate sleep, managing chronic stress, avoiding highly processed foods, and moving continuously. Because the physical damage of high glucose accrues slowly over decades, adopting these manual lifestyle interventions early significantly alters the metabolic trajectory over a lifespan. Managing the diabetes crisis depends on the consistent, daily repetition of these fundamental biological habits.